Okay, next we're gonna make a case study and see how serialization works in Java and how we might exploit it. So Java obviously has a lot more overhead. It's one of the reasons why I never show Java code snippets, because they're just too long. But serialization works essentially the same. So we have a class here, person, and it says implement serializable. Now serializable is an empty interface. Serializable is just a marker interface that marks a class, telling the Java runtime that this class can be serialized or is allowed to be serialized. Otherwise it doesn't have any methods. So we have attributes again, name, address, and age in this case, and then we have a greet function that uses the name attribute. If we serialize that again, as in every language, only the attributes will be serialized, not the code. So how would we serialize that? Well, we create a new object, person object, we set the name, the address, the age, create a file output stream, doesn't matter for now. Then we create a new object output stream where we input the file output stream, and then we call the write object method on the object output stream. So our object will be written to file in this case. Of course, we could also send it via network or something like that. To restore the object, we would do it vice versa. We would use an object input stream and read the file input stream. And then, and here's the difference to Python, for example, we read the object and then we get a generic object back and we cast it to the right type. So maybe you remember in the Python example, if we would submit another object here, the object would be read, okay, but then the code would crash here. We would get an exception, because if we would use the class dangerous or another class that we want to utilize for property-oriented programming, for exploiting, then this cast wouldn't work, because dangerous is hopefully not a subclass of person, or person a subclass of dangerous. So this cast would fail. So in order to exploit this, we would need the exploit to execute code already at this stage before the cast happens. Another side note, Java serialized data starts with the marker ACED, or in base64 that's RO0. Why do I tell you that? Well, some intrusion detection systems filter these bytes out. Okay, so how would we exploit this? As I said, we need to exploit it before this cast happens. Well, Java offers the functionality to write your own deserializer. So if we want the class person to be serializable, we can also give it an method called readObject. This gets as a parameter the object input stream and then uses this stream, for example readObject, readInt, to deserialize the class based on the stream. Now, why would we ever do that? Why would we create a class that implements readObject? Well, maybe we want to change some of the attributes that we got over the network or from a file, and as it turns out, this function is often implemented in Java distributed systems, that are systems that pass objects around. And coincidentally, these are the types of systems that we want to attack with deserialization bugs. So how would that work? Well, here's a simple example from the talk Marshalling Pickles by Christopher Frohoff. To be honest, I wanted to give you the video of this talk for Java deserialization. Unfortunately, I couldn't find a good version. I'll still give you the video and you can watch it, but it's kind of a pain to watch because the quality is really bad, unfortunately, of the recording. So what happens here, we create a Java gadget chain. Gadget chains mean we can only control attributes, but not code, but we still want to submit attributes via serialization and then make the server do something we want it to do. For example, execute code, execute commands. So, for example, in this gadget chain we have a class cache manager that implements read object. And it does so by default read object, that's the default deserialization functionality, and afterwards it calls a function called initHook. So it calls initHook, which is an attribute of the cache manager class that was deserialized, and then calls the function, the method run on the initHook. As an attacker, we can set the initHook because we control attributes. InitHook is of type runnable, so we need to find in some library that is loaded on the server runnable that does something we want it to do. Okay, so in one library there is a command task that implements runnable, and it has an attribute command, which is a string, and when run is called, what the cache manager does, it calls run, it executes runtime.getRuntime.exec command. The exec function you know from PHP, it just executes a system command, like a shell command. So our gadget chain in this case would be set a cache manager, set the initHook to a command task. In that command task, set the command to, for example, rm-rf / something you wanted to do, and then serialize that, send it to the server deserializes it. InitHook is a command task with the command rm-rf, and then initHook.run is called, and the code rm-rf is executed, the command. So we made the server execute a command we wanted it just by modifying attributes, not by changing code. Property-oriented programming. Usually gadget chains are not that straightforward and not that simple. That's what this hints to. Usually they're quite complicated and really a pain to create. It's tedious work. Here's a real example. As you can see, invoker transformer, get method. Here they work a lot with reflections as well. So as an attacker, we usually don't want to write our own gadget chains because it's a lot of work. So what can we do? Well, there's a nice tool available called serial, and it does payload. It creates payloads for us, deserialization payloads for Java, and the only condition is that certain libraries are loaded. For example, there's one exploit for Apache Commons, which is very commonly used in Java projects. I would say most big projects use it. Hibernate is a object relational mapper that's used a lot. Spring is a framework that's used a lot. So if one of these libraries is loaded on the server side, we can just use serial to generate an exploit for us. How do we do that? Well, we just call it, say serial, and then we say what gadget chain we want to use. For example, here Commons Collections 1. This is the First, there are multiple exploits for the Apache Commons library, using classes that are available in the Apache Commons library. And then we say what command should be executed. In this case, calc.exe for the example. Usually we would inject the command, I don't know. Our example was rm-rf/ to destroy something. And then what YSOSerial does is it has stored gadget chains for this library here, and then it just generates a payload here. This is the payload, and we can send this payload to the server, and as soon as the server deserializes this payload, our command will be executed on the server side.